cooking Flint Ridge with an Arduino. Alright, Jimmy's in his secret evil lab tonight, and what I'm working on is I got a new really high grade flint, and my old control program that's in my Adruino is not cooking it exactly right. And what it's doing is it's really good on the outside, but in the inside it's crumbly, and some people have told me that's because it's cooking too fast and whatnot. So this is Arduino Uno. You can buy them on eBay for like $20. This is a Max 6675. It comes with a thermocouple. It only uses 5 wires. You can see a red, which is positive, a black, which is ground, and then 3 other wires over here that actually control the sensor, and then the board reads what the sensor board tells it. That's a little adapter chip, for lack of a better word. But so my old program was pretty cool because sometimes I'll set my laptop outside and watch the flint go through the cooking. Now we'll come over, and it's going to be hard for you to see, but I've got an unsigned long, which is the period, and I can change that, which is equal to millis. I don't know why my phone quits. Let's get close so you can see. Okay. Alright, the millis is milliseconds from when the program starts running. Now for me, it's very important that I use a battery pack to run my Arduino, because if the power blanks, the whole program starts over again, which is often not good. We don't want it to do that. So millis is the time in the program that it's been running. And you can see I divide that up there by 3.6 million. And what that is 1 hour, because there's 1,000 milliseconds in a second, 1,000 and 60 seconds in a minute, and 60 minutes in an hour, and that's how that works out. Now that serial print and the serial print lines you see there are what allow me, watch when I pull up the serial monitor over here, it'll come on here and it'll show me, you can see what temperature my detector's actually reading. And 7980, that's about what it is in here. I don't use air conditioning. I have a fan. I'm not a quote fan of air conditioning, and that's how we do. Now the program is really simple, and what I have is, you come over here and you'll learn to do some programming. Arduino programming is the easiest. To me, much easier than Python, and it's based on C++, but it's easier than C++ too. And in my thing, I use an if statement. And how the if statements work is, you see over here, it says if the period, which is millis, divided by, see up here in my writing, period equals millis divided by the 3.6 million. Well, when it gets to 1 hour, that reading will be 1. And the computer's constantly running, the controller's constantly running through this. And it comes up and it checks, millis is less than 1. Millis is less than 1. Well, as soon as millis is, we can see on our screen here, as soon as millis is equal to 1, the set temperature will go to 125. And that will get further down in the program later, but I'll show you how that works. it'll go, the set temperature will go to 125. And then at the bottom, there's some more if statements, and they read the temperature and they say if it's, below set point, basically pin 13, which is my output because it has an LED on it to let me know that it's actually working, it will go high, and that will turn on this other component that we need, which is a solid state relay. And you can see I have a red and a black, a positive and negative, and this will hook up to the Arduino. And these two are the high side connections, which you would connect to the hot leg of your heating element. And when Arduino goes high because it's low, this red will go high, this LED in here will come on, this will come on. And I'm going to redo my program so that it will only come on when the line voltage is 0, because we're dealing with AC. That way I don't get surges. And if you have a kiln, I would suggest you look into that, called 0 point crossing, so that you can only come on when it's 0. And that won't shock your elements, and it will make your kiln last a lot longer if it only comes on when the crossing point is 0. Now the other thing is, we've got that. I'm not going to show you how to actually hook this up because you need to study electrical a little bit to figure this stuff out, but it's not that hard, and there's lots of YouTube videos showing you how to hook up a solid state relay to a light, which is basically a heater, or a motor, or anything actually. But a solid state relay to turn on a light will turn on your heater, or your kiln, or your turkey roaster, or your, as in my case, slow cooker. And it's easy as anything to do. Now, so as we go through, you can see my first set point is 125 degrees. I'm going to rewrite this whole program and save it as a new rock, and I'm going to change it to 100, and then I'm going to put an increment in it so that when it goes to the next hour, it will automatically add 5 degrees. And you can see here, period 1, period 2, the temperature goes up. Period 3, the temperature goes up. Period 4, the temperature goes up. And then it doesn't start going up again because I'm letting it soak for 6 hours at 200 to dry out. It doesn't start going up again till period 10. So that's 6 hours later. And then it goes up at 11, 12, 13, and so on until it hits my max temperature of 500. And then we go, and I've incremented over so I could tell where I was at. And then you see, if period is 21, that means I'm soaking at 500 for 11 hours. It'll go down to 475, so on and so forth. Now, we'll get down to the if statements at the bottom. Let me scroll my computer down. And this is really where all the magic happens. And this is where it's so easy, but I really messed it up. It said, you see that if temp less than set temp, digital write heater, which is pin 13 high. And you got to have this bracket. This is the if statement. The first curly Q is the beginning of, this is the, you got to have this if, and then temp less than set temp. The curly Q starts it. This is your condition. Okay, this first section is your condition, and then the curly Q is your action. So if the set temp is less than, if temp is less than set temp in the curly Q's, digital write heater high. And then you come down and you see you have an else statement, and that's if it's not that, then it will write the heater low. When I first did this, I didn't do that, so once it wrote the heater high, it never wrote the heater low again. And that's why I'm glad I used a serial monitor, because I could see that the heater never went low again. And I knew there was a problem. Now this delay is, it delays 1 second, and it goes through and it figures out the set temperature first, and then it checks it, and if it doesn't meet these statements, it just keeps going on and on and on. And that's how easy it is to write the program. And you see up here is, oh, I missed this part up at the top. This integer temperature equals thermocouple read, that's reading the max temp sensor, and that's where the temperature for the temperature part of that if statement is. And then it figures out what period it's in, so it gets the temperature first, figures out the period, and you have to delay here. See, I got a delay up here also, because it takes time for the processor to get that temperature update internally. It's really only 400 milliseconds, so you could delay 400, but I just delay a second and it doesn't hurt anything. And then it gets the period, and then it goes through all them ifs, and as soon as an if meets the true statement, it does the bottom. It goes to the bottom and does whatever that says. So technical flint napping, cooking information, and it's all a lot easy to learn. Arduino is very easy to learn, guys, and you can do a lot of stuff with the Arduino.